Chapter 4 deals with congruent triangles. The first section talks about congruent figures. Two polygons are congruent if and only if their vertices can be matched up so that corresponding parts, both the angles and the sides of the figure, are congruent. Take a look at these two triangles. I'm going to tell you that these two triangles may be congruent. So what I need to do first is take a look at the angle measures. Angle A has 3 arcs. Angle D has 3 arcs, so those two angles are congruent. Angle B has 1 arc. Angle E has 1 arc, so those two angles are congruent. Angle C has 2. Angle F has 2. Those angles are congruent. Therefore, all 3 angles are congruent. Now look at the sides. BC is corresponding to EF, both have 1 tick mark. AB, DE, both have 2 tick marks. And AC and DF both have 3 tick marks, which means that they are congruent. So now all sides are congruent and all angles are congruent. Therefore, triangle ABC is congruent to triangle DEF. When describing congruent figures, vertices are listed in order of correspondence. Looking at these two triangles, starting with angle A, you would start with angle D for the second triangle. So, triangle ABC is congruent to angle D, triangle DEF. I'm going from the line that has 2 tick marks, across 1 tick mark, up 3 tick marks. Same thing with the second triangle. I'm starting from D, going down the line with 2 tick marks, 1 tick mark, and then up 3 tick marks. What are the other 2 ways that you could write showing that these 2 triangles are congruent? Pause the video and write them now. Congruent polygons are the same thing as congruent triangles. 2 polygons are congruent if and only if their vertices can be matched up so that the corresponding parts, both the angles and the sides, are congruent. Please name all the corresponding congruent sides and angles for those 2 figures. Pause the video, do it now. Triangles being congruent means the following. If triangle LMN is congruent to triangle RST, then the corresponding parts are congruent. In other words, angle L and angle R are congruent. Angle M and angle S are congruent to each other. And angle N and angle T are congruent to each other. Likewise, talking about the sides, LM congruent to RS. LN congruent to RT. Line segment MN is congruent to line segment ST. Part 2, if corresponding parts are congruent, then the triangles have to be congruent to each other. This leads us to our first postulate. And the postulate says you would write that corresponding parts of congruent triangles are congruent. Notice how it's written, corresponding parts of congruent triangles are congruent. However, one of the best abbreviations that you're going to have all year is CPCTC. You'll actually be able to use CPCTC when you're doing proof. There are some special cases that you will encounter when you have something like an isosceles triangle or 2 isosceles triangles like what are shown here. In that case, you have multiple pairings of vertices. While you notice that angle F and angle A are the ones that are congruent, showing only 1 arc, angle D and angle E are both congruent in the left triangle, and angle B and angle C are both congruent to each other in the right triangle, and D, E, B, and C are all congruent to each other. Therefore, if I were going to name the triangles that are congruent, I could say triangle FDE is congruent to triangle ABC, or triangle FDE is congruent to triangle ACB. You get the picture. Now that you have the basics, please make sure you go and finish your note sheet.